Okay, so in this lesson, we're going to be learning about sequences and series, and specifically arithmetic sequences and arithmetic series. Any function where the domain is a set of positive consecutive integers forms a sequence. In other words, sequence is just a list of terms or a list of numbers. So the domain is like the first term, the second term, the third term, the fourth term. And therefore, the domain is just your positive consecutive integers. And we say that this is discrete data. Then the values in the range are the function are the terms of the sequence. When naming a term in a sequence, subscripts are used rather than traditional functional notation. So instead of us saying f of 1, we would say like a sub 1. And a is just a general letter they use, but we can use any letter. I mean, you can make a sequence and call it sequence B or C or D. It's just like anything. It's like f of x, g of x, h of x. You can just change it up. So let's consider the sequence that we have here, 4, 6, 8, 10, 12, 14. Just to explain the subscript notation, we would say a sub 1 is equal to 4. And what all that means is the first term is 4. A sub 2 is equal to 6. A sub 3 is equal to 8. A sub 4 is equal to 10. And if we kept going, a sub 5 would be 12. A sub 6 would be 14. So the little subscript just refers to which term in the sequence we're talking about. In this case, because this sequence is adding 2 each time, if we came up with a formula that would work for this sequence, it would be a sub n equals 2n plus 2, where a sub n represents the nth term of the sequence. So when you see that, that's just saying, you know, like if you substituted 1n, you would get a sub 1. If you substituted 10n, you would get a sub 10, meaning the 10th term. And n represents the term number, which term we're talking about. A sub 6 means the 6th term of the sequence. So it's just trying to kind of explain to you that subscript notation. All right, so today we're going to focus more on what we call arithmetic sequences. And I know when you see that term, you probably say, Miss Salter, that says arithmetic. And it can be pronounced arithmetic, but when we're talking about sequences and series, we actually pronounce it arithmetic. So an arithmetic sequence is a sequence in which the difference of consecutive terms is constant. So what that means is if it is an arithmetic sequence, you're either adding the same number over and over again, or you're subtracting the same number over and over again. We say the arithmetic sequence have a common difference, and the common difference is the same thing as a constant difference. If you were to graph out a sequence that's arithmetic, it would make a linear pattern. So that constant difference or common difference is the same thing as the slope or the constant rate of change. All right, so let's look at the try these A. Determine whether each sequence is arithmetic. If the sequence is arithmetic, state the common difference. So why don't y'all pause the video and try that real quick and then start the video back. Okay, so the first one is arithmetic because we are adding 5 to each term to get the next term. So the common difference 5. The second one is not arithmetic because it's doubling. So if you see a multiplicative pattern or a squaring pattern or some other type of pattern, it doesn't mean that it's not a sequence. It's just not an arithmetic sequence. The third one's also not arithmetic. This is actually called the Fibonacci sequence, and it's a sequence often found in nature. It's kind of neat. We're going to work on this later. In this unit, we have to use a recursive formula to write the sequence because what you're doing is you're adding the 2 previous terms to get the next term. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5, and so on. The last one is arithmetic because we're subtracting 3 to get the next term, so the common difference is -3. So just remember, in order for it to be an arithmetic sequence, we're either adding or subtracting the same number over and over again. All right, so the general formula for finding any term in an arithmetic sequence, or to be able to write a formula to describe the arithmetic sequence, is a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 is the first term, d is the common difference, n is the number of the term, or number of terms, depending on how you're using the formula. And a sub n represents the nth term of the sequence. All right, so let's look at example 2. Use the formula to find the specified term in each arithmetic sequence. So for question A, Find the 40th term when the first term is 6 and the common difference is 3. So literally, we're just going to substitute straight into this formula that we just got. Instead of saying a sub n, we will say a sub 40 because that's the whole idea. We want to find the 40th term. All right, and then we'd set that equal to a sub 1, and a sub 1 is 6 plus n minus 1. So if n is 40, n minus 1 is going to be 39 times the common difference, which is 3. And then we would just calculate that, so we'd have a sub 40 is equal to 123. And what that means is the 40th term of this sequence, where the first term is 6 and the common difference is 3, would be 123. So this one says find the 30th term of 37, 33, 29, 25. So we got to pick out a few things first. First of all, n is going to be 30. That's the whole idea. We want to find the 30th term of this sequence. We want to find what a sub 30 is. We also, if you look at the pattern, you can see that it's subtracting 4 each time to get to the next term. So the common difference is negative 4. And then the first term of this sequence is 37. So we're going to pop that into our formula. So a sub 30 equals a sub 1, which is 37, plus n minus 1. So if n is 30, we're going to add that common difference 29 more times because we're already at the first term. So to get the 30th term, we'd have to subtract 4 29 times and then times that common difference. And then we just pop that together. So a sub 30 is equal to negative 79. We can also use technology to set this up. If we were to write the formula without substituting n into the formula, so we'd have a sub n equals 37 plus n minus 1 times negative 4. We could put this in our calculator in y equals. Of course, we would use x instead of n. And then we could go to the table and look when x is 30, what is the value of y? So we would just go in our calculator, click y equals, type in our formula, and then all we have to do is go to our table. So second graph, go to the table, and of course we would want to look when x is 30. Now, I don't want to scroll there all day long, so I'm going to go real quick, second window to my table setup, and I'm going to start this at 30, and then press enter, and then go back to my table so that I don't have to sit there and scroll all day long to 30, and I can look and see that the answer is negative 79. Okay, so this one says write an algebraic formula for the sequence 2, 5, 8, all the way down to 20 in terms of n, the term number. All right, so if I'm looking at the sequence, we can see that the first term is 2, and we can see that the common difference in this case is 3. And so we want to come up with a formula to work. So we're going to use our formula that we learned above. So a sub n equals a sub 1, which is 2, plus n minus 1 times 3. Now, I do not want you to leave this like this. I want you to clean it up. So something that might be good when you're actually writing a formula for some of y'all is put that 3 in front of the n minus 1, because when we like to distribute, it's a lot easier to distribute from the front than the back. And then we're going to distribute right here, so that gives us a sub n is equal to 2 plus 3n, and then 3 times negative 1 is negative 3. And then when we combine like terms, we get that a sub n is equal to 3n minus 1. Again, you can check to make sure your formula works by substituting in 1, 2, 3. Like if I substitute 1 for n, 3 times 1 minus 1 gives me 2. If I substitute 2 for n, 3 times 2 is 6, minus 1 gives me 5. And kind of just check to make sure you're getting the right terms. You can also check it by putting it in your calculator, just like we did the last one, and go ahead and type in 3x minus 1 and go to the table and make sure that the first term shows 2, the second term shows 5, and so on. All right, which term in the sequence in part C gives the term a sub n equals 20? Well, now that we have our formula, we can just use that and substitute 20 for a sub n. So using the formula that we just learned, we would say, okay, well, 20 is equal to 3n minus 1. We would then add 1 to each side. 21 is equal to 3n. And then divide each side by 3 to get that n is 7. And we can see that it would be the 7th term of the sequence. Of course, using technology, you could also set it up, like I just said, in your calculator table and see that when you get to x is 7, where x represents n, that it gives us the term 20. Make sure when you're doing this that you understand that this needs to be a positive integer. If you were to work this out and it said n was 6.5, something's wrong, because you can't have a 6.5 term. You either have a first term, second term, third term, so on. So be careful about that. Go ahead and try question A and B in the Try These B. Pause the video, and when you're done, start it back to see how you did. All right, so for A, we should get negative 91, and for B, we should get 111. You can see that these problems do not take a lot of work, but guys, when you are showing your work, you need to at least show me a setup. If I'm giving you this problem and all I see is negative 91 written down, I'm going to be like, where did you get that from? It doesn't take that long to jot down a few steps, so try to pretend like you have absolutely no technology when doing these. Actually write out your steps, and then if you use your technology to do some basic calculations, that's fine. But you should show some work here. Problem C, which term in the arithmetic sequence 15, 18, 21, 24 is equal to 72? So we know the first term is 15. We know the common difference is 3 because it's adding 3 each time. We know that the nth term is 72. What we don't know is what is that term. So this is similar to the problem we did on the front side of this sheet. So I want y'all to try it. When you're done, start the video back and see how you did. Pretty much what you're really doing is writing a formula for it. And you could break this up into 2 steps. You could write the formula and then substitute 72 in. I just did it all at once and then worked it out. Make sure that you're careful and that you distribute that 3 to both the n and the -1. If you need to, rearrange it so you can distribute from the front and not the back. So we clean this up. We get 3n plus 12. That is the formula that expresses this sequence. And then we work it out by subtracting 12 and then dividing by 3 to get it's the 20th term. All right, let's look at this last one. This one's a little bit different. It says, find the first term and the common difference when the 8th term is 9 and the 13th term is 24. What y'all have to remember is an arithmetic sequence creates a linear pattern. So if we don't know what the common difference is, it's the same thing as not knowing what the slope is. So that's what you're going to use to figure this out. So I'm just going to make a little table real quick. What this is giving us, if we have our domain, remember, is n, the number of the term, and our range here is a sub n, the actual term. So right here it told us that the 8th term was 9 and the 13th term was 24. All we have to do is figure out what was that common difference. So from 8 to 13 was 5 terms, and from 9 to 24 is 15. So if we divide those, it's the same thing as the change in y of the change in x. It's the same thing as finding the slope. 15 divided by 5 would ultimately give us 3. And that is what the common difference is going to be. You can also do this by using your slope formula. You can set it up like that. You could say, okay, well, d equals 24 minus 9 over 13 minus 8. And so we would get 15 divided by 5, which is 3. It doesn't matter to me how you do it as long as you can figure out that that common difference is 3. So once we know that the common difference is 3, we now have to find the first term. So we're going to need to use some of our information here. So real quickly, I'm going to write the formula again. Remember, the formula is a sub n equals a sub 1 plus n minus 1 times d. All right, so I'm going to use this bit of information right here. I'm going to use the fact that I know that a sub 8 is equal to 9. And so that's what I'm going to substitute in here. I'm going to do a sub 8 equals a sub 1 plus, and since I'm going to use 8, n is going to be the 8th term, so I'm going to say 8 minus 1 times d. So now I'm going to substitute everything in. So since we know that a sub 8 is 9, right here we're going to substitute 9 for a sub 8. The idea is we want to find a sub 1 plus 7 times d. And d we already found to be 3. So we have 9 is equal to a sub 1 plus 21. We would then subtract 21 from each side, and we get that a sub 1 is negative 12. And you could always reset this up to check it in your calculator, or just to check it, you could substitute negative 12 for a sub 1 and 3 for d, and just like we did that other problem, put it in your y equals, and then go look, is the 8th term 9, is the 13th term 24, and make sure that it checks out. All right, so now we're going to move from sequences to series. A series is the sum of the terms in a sequence. The sum of the first n terms of a series is the nth partial sum of the series and is usually denoted by S sub n. So, for example, if I wanted to find S sub 6, what that means is I want to find the sum of the first 6 terms of that sequence. The difference between a sequence and a series is a sequence is just a list of numbers, and they are separated by commas. Where when you do a series, you're actually adding up those numbers. So they're actually, instead of having commas in between them, you write them with pluses because you're actually going to sum it up. So let's look at this first arithmetic sequence, 4, 6, 8, 10, 12, and so on. Let's say that it says, write a sequence for the first 4 partial sums. Okay, well, pretty much what we're going to be doing here then is just adding the first couple of terms together. So if I start with the very beginning, if I just want to find S sub 1, it's just 4 because I don't have anything to add to it. It's just the sum of the first term. But if I want to find S sub 2, it's the first term plus the second term. So it would be 4 plus 6, which would give us 10. S sub 3 would be the sum of the first 3 terms, 4 plus 6 plus 8, which would give us 18. S sub 4 is the sum of the first 4 terms, so 4 plus 6 plus 8 plus 10, which would give us 28. So this is pretty much what we just did was we wrote a sequence of the first 4 partial sums. Then it says find S sub 5. So since we already found S sub 4, all we would need to do is take the sum of the first 4 terms, which is 28, and then add that 5th term to it, which is 12. So that would give us 40. Go ahead, find S sub 8. All right, so to find S sub 8, we would take S sub 5, because we've already added up those first 5 terms, which is 40, and then add that 6th term and the 7th term and an 8th term to that, which gives us a total of 88. All right, now what I would like for you to do is I would like for you to find A sub 1 plus A sub 8, and then compare it to A sub 2 plus A sub 7, A sub 3 plus A sub 6, and A sub 4 plus A sub 5. Pause the video and then start it back when you're finished. All right, well, hopefully you could see after you find those different sums that they all sum to the same number. They all sum to 22. So explain how we could find S sub 8 using only the value of the first term plus the 8th term. Well, since we had 4 different groups, we would say 4 times that sum of 22, which would also give us 88. And we can check that with when we found S sub 8 in part C, and we can see that they are the same. All right, so let's make a generalization here. Consider the following arithmetic series. So this is just using notation from the first term all the way to the nth term. How many number of pairs of terms are there in this series? Well, if we're just generalizing it, if there's n terms in the total series, then the number of pairs in this series would be n divided by 2. So if pretty much what happens is if we know what the first term is and we know what the very last term is, then we can just add the first term to the last term and then multiply it by the number of pairs in the series and get the total sum. So the formula for the sum of the first n terms is going to be S sub n is equal to n divided by 2 times A sub 1 plus A sub n. And that's how we're going to find the sum of the first how many ever terms it wants us to find. This formula, n is the number of terms, A sub 1 is the first term, A sub n is the last term you're adding to. In other words, the nth term. So if it says find S sub 10 or the sum of the first 10 terms, n is 10. And then S sub n is the sum of the n terms. So in other words, like the sum of the first 10 terms or 12 terms or whatever it wants you to find. Let's put this formula into practice. So we have S sub n equals n divided by 2 times A sub 1 plus A sub n. So the first one, we can see the first term is 3, and it wants us to find the sum of the first 20 terms. That's what S sub 20 means. Well, it didn't tell us what the 20th term is, so what happens is we have to find the 20th term first. For all these problems, you end up having to use both formulas at some point. So we know the first term's 3, we know the common difference is 5, we know we want to sum the first 20 terms, but in order to do that, we need to know what the 20th term is, and we do not know that. So we have to go back to our first formula. So that's going to be step 1. We're going to calculate the 20th term. So a sub 20 equals the first term plus n minus 1, which would be 19, 20 minus 1 is 19, times the common difference. All right, so when we work that out, we get that the 20th term is 98. Now we have the pieces we need in order to find the sum of the first 20 terms. So we're going to say S sub 20 is equal to 20 divided by 2. If there's 20 terms, that means there's 10 pairs. It's okay if there's an odd number, it just works out. So if it was like 19 terms, it's fine. You just do 19 divided by 2 right there. And then we'd say times the first term plus the last term that we want to sum to, which is the 20th term, which we just found to be 98. And then we would put that together, so that is 10 times 101. So we get that the sum of the first 20 terms of this sequence is 1,010. And that's our final answer. All right, why don't y'all try the next one? Pause the video. When you're finished, start the video back. Okay, so this problem is just like the last one. We know the first term. We can see that the common difference is -2 because it is subtracting 2 each time. We know we want to sum the first 18 terms, but we do not know the 18th term. So we start out, we use our first formula we learned, and we find the 18th term. Once we know what the 18th term is, we substitute into our second formula. It's the first term plus the 18th term, and then we multiply it by the number of pairs, which is 9 pairs, and we get that the sum is -342. Okay, try the next one. This one's a little bit different. It says find the first 3 terms of the arithmetic series. If the first term is 4, the last term is 31, and the sum of all those terms is 175. Push yourself. See what you can come up with. Which formula would you need to use first given that information? We're in honors pre-cal. You're going to have to learn how to problem solve. So see what you can do and then start the video back. So looking at the pieces we have, we are going to have to actually start with the summation formula this time to figure out how many terms are in this sequence or this series. So we're going to substitute in what we have. We have that the sum of the first n terms is 175. We don't know what n is. We know that the first term is 4 and the nth term was 31. So we work that out. That is going to give us 175 is equal to n divided by 2 times 35. So I'm going to go ahead and actually divide by 35 on each side first. So that leaves us with 5 is equal to n divided by 2. And then I'm going to multiply each side by 2. So we end up with 10 is equal to n. So now we know that there are 10 terms in this sequence or series. The next thing is we don't know what the common difference is. So now we can come over to this formula because, again, we know that the nth term, which we now know is the 10th term, is 31. We know that the first term is 4. Since we now know that there are 10 terms, 10 minus 1 would give us 9. But we need to figure out what that common difference is. So we'd subtract 4 from each side. We get 27 is equal to 9d. And then divide each side by 9, and we get 3 is d. Now we can put it together and find the first 3 terms of the arithmetic series. So the first term would have been 4. The second term would have been 7 because 4 plus 3 is 7. And the third term would have been 10. Okay. Try these C. And go ahead and see what you can do with example 7 and then start the video back. Okay, so these 2 problems are like the ones we did above at the top of the page. Pretty much you just have to figure out what that nth term is, the first one the 10th term and the second one the 25th term, and then substitute into your formulas to find the sum of the first 10 terms and then the first 25 terms. Make sure you pause the video if you need to correct something or fix it. All right, looking at the last one, this one, what I would do is I would make a table of the information given. And that's what you'll see I've done here. It tells us that the first row has 3 cases, and then each row from there will increase by 4. And so I just kind of went ahead and started making a pattern so I could see what's happening. So it says, let R sub n denote the number of cases in the nth row of the display. Guys, it's okay if it's not A sub n. You can call it whatever you want. So don't get caught up by that. R sub n is the same thing as A sub n. So we just use our little formula, and we substitute in our first term is 3. Our common difference is 4. We distribute, clean it up, and we get the formula that would represent n terms, or n rows, in other words, is R sub n equals 4n minus 1. Then how many cases will there be in the 7th row from the top of the display? Well, I already made a table, and I can see that there's going to be 27 cases. However, if I wanted to make sure my formula worked, I might want to check it and do it that way too. And I can see that that matches that my formula does work, because when I substitute 7 in, I get 27 cases. All right, let T sub n denote the total number of cases in the display for n rows. Okay, so as soon as you see this, guys, right here, this total number, that's talking about summation. We're going to add all those cases up. So pretty much this is the same thing as our S sub n formula, but it's going to be our T sub n formula. The deal is, though, we don't know what the nth term is. So what we're going to do is we're going to substitute our formula for the nth term and make a little formula here. So we substitute our first term being 3, and then for our nth term, 4n minus 1. And then I just cleaned it up a little bit. What is the minimum number of rows needed for the display if the Harris-Teeter manager wants at least 150 cases used for the design? All right, so what you're pretty much doing is you are setting up what would n need to be if our answer is 150, if it's equal to 150. Now, you could work this out algebraically, you could distribute, it makes a quadratic, you could, use quadratic techniques to solve it. You can also use technology, that's a lot quicker. So once I set up this formula, I just went into my y sub 1, I typed the formula in with x instead of n. I went to the table and I could see that for 8 rows, there would be a total of 136 cases. Remember, we're using our total formula, our summation formula, not our nth term formula. And then 9 cases would be 171. So if they want at least 150 cases, we would have to go with 9 rows. And if we need to, we can discuss this further in class.